Hello everyone, welcome back to CloudOps Craft. Today we are going to discuss interview questions regarding Docker networking. Previously, we discussed about Docker basics and core concepts interview questions, and images, layers, and registries questions, and Dockerfile and build process interview questions. Okay, today we are going to discuss about Docker networking. If you haven't watched part 1 to 3, I suggest you to watch. Okay, because if you know all that concepts, it will be better for you to understand this also. Okay, that's the only reason. Okay, so let's start. First question is, what is Docker's default network? Okay, so the thing is, if they ask this question, interview context will be, this is a basic but important question to check whether you know Docker's out of the box networking behavior, how containers are connected. If you don't do anything special, let me explain this. By default, Docker creates a bridge network called bridge, like which is like a baked by the kernel bridge device, typically named Docker 0. Okay, when you run Docker run without specifying hyphen network, Docker attaches the container to that default bridge. Containers on the default bridge get an IP from the bridge subnet. Okay, can reach the internet via NAT. Okay, and it can be reached from host via published ports, but the default bridge has limited automatic DNS name resolution compared to user defined networks. So how to answer an interview? Okay, Docker's default network is the bridge network, the Docker 0 bridge on the host. If you don't specify a network, containers attached to that bridge and get an IP from the bridge subnet. For production networking, I prefer user defined bridge or overlay networks because they provide better isolation and automatic DNS. Okay, this is how we have to explain. Next is difference between bridge, host, and none networks. Okay, if they ask this question, interview context will be like interviewer expects a clear difference and typical use cases for each network mode. Okay, let me explain. Okay, so first is bridge. Let me zoom this better. Yeah, bridge network. Okay, this is a default network as we discussed now. Docker creates a private namespace, okay, and veth, okay, virtual Ethernet, okay, veth pair for the container. The container has its own network stack and connects to a bridge on the host, okay, which is Docker 0. NAT and IP tables forwards host port to container ports when you use -p, which is publish. Okay, good for isolation, single host setups. Okay, first is bridge, right? Second is host. Okay, container shares the host network namespace directly, no network namespace created. Container processes bind directly to the host interface. Pros is low latency and no NAT. Okay, cons is no isolation, port collisions with host. Common for performance sensitive apps or when you must access host network interface directly. Okay, none network. Okay, third is none. None is like a no network interface or created for the container. Okay, only loopback, useful for highly isolated workloads or when you intentionally manage networking yourself. So how to answer an interview? So bridge gives each container its own network namespace and uses a host side bridge with NAT. Host mode shares the host network stack, okay, which is no NAT, and none gives the container no network interface. I use bridge for most apps, host for low latency or special NIC use cases, and none for isolated debug test workloads. This is so we have to explain. What is the third question? How do containers communicate within the same network? If they ask this question, interview context will be they test if you understand container to container communication, name resolution, and the role of the network driver. Okay, let me explain this. Containers on the same user defined network get IPs from the network subnet, okay, and can reach each other directly via IP and by container name, okay, which is Docker's embedded DNS. Okay, Docker setup virtually net v Ethernet, okay, v pairs that connect container interfaces to the bridge. Traffic between containers on the same host is switched by the bridge, no NAT if they use internal IPs. If across a host, which is overlay, packets are encapsulated and routed across the cluster's overlay fabric. So how to answer an interview? So containers on the same network communicate using their internal IPs, okay, or service container names via Docker embedded DNS on user defined networks, okay, locally the bridge switches packets, and in multi-host setups the overlay driver encapsulates and tunnels traffic between hosts. This is how we have to answer. Next is, what is container DNS resolution? Okay, if they ask this question, the interview context will be they are accessing whether you know uh, how Docker resolves names and when embedded DNS is available. Let me explain this. Docker provides an embedded DNS server. Okay, it is commonly reachable at 127.0.0.11. Okay, inside containers. Okay, for user defined bridge and overlay networks. Okay, this DNS resolves the container names, service names, and container aliases. Okay, on the default bridge, automatic name resolution is limited. Historically, we will use link was used to share host names, but it is depreciated. Okay, so Compose and Swarm create user defined networks that give you predictable DNS based service discovery. Example, HTTP resolves to the service VIP or task IPs in Docker Swarm. So how to answer an interview? Docker runs an internal DNS on user defined networks which resolves container and service name. Okay, so that's why in Docker Compose you can refer to a service by name. The default bridge is less featureful, so for name based discovery I use user defined networks or overlay networks in orchestrators. Okay, this is how I have to explain. Next question is, can containers on different networks communicate? Okay, here interview context will be they will check if you know network isolation and when cross network communication is possible. Okay, let me explain. By default, containers on different Docker networks are isolated and cannot talk directly. To enable communication, you can attach a container to multiple networks. A container can have multiple interfaces IPs. Okay, and you can create a NAT gateway and a relay container or use the host network. Okay, use orchestration tools like Kubernetes or service discovery or external routing. Okay, cross network communication is an explicit decision in Docker. Okay, isolation is the default. So how to answer an interview? So you can answer like no, separate Docker networks are isolated by default. If they need to communicate, either attach the container to both networks, create a dedicated network that both join, or use an external router service mesh. I prefer explicit network design so services only see what they must. Okay, this is how I'll answer. Okay, this is how if you answer it will be good. Okay, what is port mapping? Okay, if they ask this question, they want you to explain the concept of exposing container service to the host and the external world. Okay, let me explain. Port mapping. Okay, port mapping, like a port mapping forwards a port on the host to port inside the container. The CLI flag, what we will use, -p, right? -p, host to port and container port. This is the syntax. Okay, our compose ports uses it creates IP tables. Okay, NAT rules. So traffic arriving on the host port is denatted to the container IP. Okay, container IP port. Okay, expose in Dockerfile is metadata only metadata only, okay, and does not publish ports, okay. You still need -p or ports to make a container accessible from outside its network. So how you can answer this? Port mapping binds a host port to a container port using NAT rules, enabling external access, okay. Expose is just a metadata, okay. In Dockerfile you will use expose, right? It's just a metadata, okay. To reach a container from outside the host, you must publish a host port, okay. You have to use this while you are running your container, okay. So the next question is, what happens behind -p 8080 colon 80? This is also a continuity question, okay. So if I use a -p 8080 colon 80, what will happen then? If they ask this question, they expect a low level explanation of NAT, V, ETH, and IP table changes, okay. So the thing is, whenever you run docker run -p, for example, if you run docker run -p 8080 colon 80 image name, okay. So Docker, what it will do, it creates a container and assigns it an internal IP. For example, consider the internal IP should be something like 172.17.0.5. It adds second step of this is first step, okay. Second step, what it will do is it adds IP tables and NFT tables rules, okay, that DNAT incoming packets on the host port 8082 this our IP, okay, the assigned IP, okay. So third step, what it will do is it will ensure written packets are SNATed, so the container response goes back to the host network interface and out to the client, okay. So fourth step will be like if you are using Docker Swarm, okay, routing mesh, published ports might be handled by overlay or ingress routing rather than just per node DNAT, okay. So how to answer this? So -p 8080 colon 80 creates IP table NAT rules, okay. So traffic to host port 8080 is forwarded to container port 80, okay. How it works, it creates IP table NAT rules, okay. So Docker handles DNAT and SNAT, so responses route correctly. So on Docker Swarm, there is also routing mesh which can expose the service across us nodes differently, okay. So the next question is, handling multiple how does Docker handle multiple containers exposing same port? Here interview context will be they want to know about host port collisions, internal ports and orchestration patterns, okay. So let me explain. First we will discuss about inside container, okay. Here we have you need to know about inside container, host port publishing, okay, and its solutions, okay. So first we will discuss inside container. Inside container, multiple containers can listen on the same internal port, example 80, because each has its own network namespace and IP, right? So while coming to port publishing, host port publishing, two containers cannot bind the same port on the same host. For example, you can't use -p 8080 colon 80 on two containers. The second will fail because the host port is already in use. Okay, what is the solution then? Publish to different ports, okay. For example, one container uses 8080 colon 80, another content create with 8081 colon 80, okay. Run behind a reverse proxy or load balancer, okay, that routes by host header, or use orchestration that provides a service abstraction like example Kubernetes, okay, and load balancers across a pod, okay, pod and tasks, okay. How to answer an interview? Containers can bind the same internal port because they are isolated, but but you cannot map the same host port to two containers on the on one host. That collides. Okay, so in production we run many containers on internal ports and use a load balancer or service mesh to expose a single external port and distribute traffic. Okay, this is how we have to answer. Then next question is, what is overlay network? Okay, if they ask this question to you, the entry context will be, this checks multi-host networking knowledge, how containers on different hosts are connected. Okay, so let me explain. Overlay networks let containers on different Docker hosts communicate as they are on the same level 2 level 3 network. Overlay implements tunneling, okay, commonly VXLAN, to encapsulate container traffic between hosts, providing a shared virtual network across the cluster. Okay, use cases, if you are using Docker's firm service, multi-host compose setups, or any scenario where containers on different hosts need simple, okay, so L3 connectivity and service discovery. Okay, so overlay also integrates with the service discovery DNS to resolve service names across the cluster. For example, the thing is, let me explain with the diagram. Okay, so container, we have a host okay, and this is my container 10.0.0.2. Okay, host B. Okay, again here I am container IP is 10.0.0.3. Okay, so how it will connect? With the help of VXLAN tunnel. Okay, so this is how overlay works. Okay, so how to answer an interview? Overlay networks provide multi-host container networking by encapsulating packets, which is VXLAN, okay, between Docker D. Okay, they enable service discovery and cross node container communication without complex manual routing, ideal for customized deployments. And the next question, networking in Docker's firm. Okay, how networking works in Docker's firm? If they ask this question, they are checking understanding of service abstraction, ingress, routing rules, and overlay specifies. Okay, let me explain. In swarm mode, okay, services are deployed as tasks, okay, across us nodes. Swarm creates an overlay network for service tasks so they can talk via service names. Next is service discovery and VIP. Okay, Swarm assigns a virtual IP, VIP. Okay, that only I am calling as a VIP. Okay, per service. Talks behind the VIP are load balanced. Next is routing mesh and ingress. Okay, when you publish a port on a service, Docker exposes that port on all nodes, which is routing mesh. Okay, any node receiving traffic for the published port will route it to one of the service task, even if the task is not on that node. This uses ingress load balancing and encapsulates are needed. Okay, while coming to control plane, manages maintain state and control networks, works host tasks. Okay, so how to answer an interview? Swarm uses overlay networks and a service abstraction. Each service gets a VIP and a DNS entry. Published ports are exposed on every node via routing mesh, which routes incoming traffic to service task regardless of where they run. Okay, manages coordinate network state and distribute routing information. Okay, so next is how to inspect container network. Okay, they want to see if you know the diagnostic commands and what to look for IP gateways, routes, and DNS. Okay, so let me open the server and I will teach you some useful commands and places to inspect. Okay, first is you can use Docker network ls. Okay, so it will list networks. Second, you can inspect it using Docker network. Okay, inspect and your network name. For example, bridge means bridge network ID. Just copy the ID and paste it here. Okay, so it will show subnet. Okay, it will show subnet, gateway, connected containers, IPAM config, everything you can see. Okay, so next is you can do after doing inspect. For example, if you are running any containers, then you can inspect that container also. For example, if I use Docker PS, I'm running one container, right? So I'll just try to inspect it. Docker inspect. So here it will shows IP, MAC, okay, network mode, exposed reports, everything it will show. Okay, you can see. Okay, next is you can use Docker exec -it and container name. Okay, and even you can run IP addr. Okay, all those things to inspect from inside container. Okay, so while coming to host level tools, you can use bridge IP or link IP tables. Okay, to check DNAT rules. Okay, look for IP assignment, gateway, DNS server. Okay, for embedded DNS and whether the service port is listening. Okay, you can use SS secure socket LTNP in. Okay, and you can even do this in the inside the container also. Okay, to check your address port, all those things. Okay, how to answer an interview. So how you can answer is, I start with Docker network inspect to verify network config, and a Docker inspect and container name for network settings. Then I execute into a container to check IP ADDR and SS. For example, and I'll check even /etc/resolve.conf, and on the host I'll check bridge interfaces and IP tables and NAT rules. That sequence usually shows whether the problem is DNS or routing or IP tables where we are having problem. Okay, so this is how you can explain. Next is real world scenario. Okay, containers cannot reach DB. What's troubleshooting path? Here entry context will be, this is a practical troubleshooting scenario accessing methodological debugging across this app, containers, network and infra layers. Okay, let me explain I'll provide a detailed explanation so you will have good knowledge. First step how you can debug is, first is reproduce and capture error. Reproduce and capture error. The thing is, note exact app error, timeout or connection refused or DNS error. Second is, check container networking. Check container networking. Like how you can check container networking? You can use Docker exec into app container and try. Okay, you can use ping command. Okay, if ping allowed it. Okay, you can use getnat, get host, db host. Okay, or even you can use ns lookup. Okay, to test name resolution. And you can use SSIF1LTN, or you can even use telnet. Okay, to test IP connectivity, TCP connectivity. Okay, so third is, you have to validate DB reachability from host. Validate DB reachability from host. Okay, can the host reach DB? You need to question this. Okay, this separates host versus container network problems. Next, what you have to check while coming to debugging is, check service binding on DB. Check service binding on DB. Okay, it ensures DB is listening on the expected interface, whether it is 0.0.0 or 127.0.0.1 under port. Okay, next is inspect network, Docker networks. Inspect Docker network. Okay, Docker network inspect command you can use to check if both app and DB are on same network or if DB is in different network and host. Okay, next is you can even check published ports. Okay, you can check for published ports, firewall, and security group. Okay, host, firewall, IP tables, cloud security groups, all these things you can verify whether everything is correct. Okay, next is you can check for authentication and credentials. Okay, verify connection string and credentials and that TLS settings, all those matches. Okay, next is check logs and resource issues. I'll check DB logs for reused connections or connection limits. Check container resource limits, C group that might block connections. Okay. Ninth is even if multi host or overlay setup. Okay, if it is a multi host or overlay setup, check overlay and manager status. Okay, check VXLAN tables or routing mesh. Okay, next is uh, escalate. Collect outputs, Docker inspect network configs logs, and if needed, open infra ticket. Okay, so how to answer an interview? I could follow a methodological path, read the exact error, execute into the app container and test DNS and TCP connectivity, inspect Docker networks to ensure both services are attached where expected, verify the DB is listening on the right interface, and check host firewalls and security groups. If it is an overlay or multi-host setup, I also check routing mesh and manager health. I collect logs and config output at each step so I can pinpoint whether the issue is DNS or routing or firewall or service binding. Okay. So the next question is, what is IPAM? Here, if they ask this question, the entry context will be they want to confirm you know how Docker assigns IPs and manage subnets for networks. Okay, IPAM stands for IP address management in Docker. Okay, so in Docker, the network drivers IPAM subsystem allocate subnets and IP addresses to networks and containers. When creating a network, you can specify subnets, gateways, and IP tables. Otherwise, Docker assigns them automatically from default pools. IPAM tracks which IPs are in use per network and prevents collisions. Okay, in advanced setups, you can integrate custom IPAM plugins for external allocation policies. Okay, so how you can answer an interview? IPAM is Docker IP address management. Okay, it allocates network subnets and container IPs for Docker networks, and you can also customize subnets and gateways when creating networks. Otherwise, Docker assigns them from an internal pool. For complex setups, we can use IPAM plugins. Okay, the next question is MAC address assignment in containers. If they ask this question, the entry context will be this checks if you understand how containers interfaces are represented on the host and whether MACs are configurable. Okay, let me explain this. Docker creates a container network interface. Okay, it creates a vEth pair. One end inside the container ETH0, okay, ETH0, okay, and other attached to the bridge on the host. Docker generates a MAC address for the container side interface, typically random but deterministic in some drivers. Okay, you can explicitly set a MAC address with using -mac address or at Docker and also if needed. Okay, on bridges, the host will see the container MAC on the bridge port. Okay, and a normal L2 switching behavior applies for local container to container traffic. So how you can answer? Docker creates vEth pair for the container and assigns a MAC to the container interface, usually generated automatically. You can specify a MAC with -mac address if necessary. The container MAC is visible on the host bridge and used for L2 switching on the host. Next question is common mistakes with the container ports. Okay, here the context will be interviewers want to see you have experienced pitfalls and can avoid or debug them quickly. So let me explain. Okay, like a common mistakes and why they break things. Okay, first is binding service to first is binding service to localhost 127.0.0.1 inside container. Okay, service is the only reachable from inside the container, which is loop back, okay, and not from other containers or host, okay. Should bind to 0.0.0. Okay, next is confusing expose versus -p. Okay, this is major issue. Confusing expose that you will use in Dockerfile versus -p that you will use in Docker run. Okay, expose does not publish the port to the host. Okay, forgetting -p causes services to be unreachable from outside. Remember this. Third is port collisions on host. Okay, trying to publish the same host port for two containers on the same host, okay, it will fail. Fourth is not publishing ports in compose. Not publishing ports in compose. Okay, services may be isolated unintentionally. Okay, so next is assuming host mode. Assuming host mode equals published port freedom. Published port freedom. Okay, so host mode makes the container share the host stack and can cause accidental exposure and collisions. Okay, so the next step, debugging step is firewall or security group overlooked. Firewall or SG overlooked. Cloud SGs are cloud security groups. Okay, AWS security group. Okay, or some other cloud provider. If you are using security groups or host firewalls, block traffic even when Docker mapping is correct. So you have to check your inbound rules. Okay, in security group. Next is forgetting to allow container to container traffic when using custom networks. Okay, wrong network choice can isolate service. Okay, next is misunderstanding ephemeral ports and long lived connections. NAT timeouts or track limits can drop connections under load. Okay, so how to answer in interview? So common mistakes include binding apps to 127.0.0.1, making them unreachable, assuming expose publishers ports, colliding host ports, and ignoring host and cloud firewall rules. Okay, I always check the app binds to 0.0.0.0, verify published ports with Docker PS, inspect IP tables and network rules, and test connectivity from outside and inside the host. Okay, this is how we have to answer. Okay, so this is all about Docker networks, Docker networking. Okay, interview questions. Okay, if you like this breakdown, subscribe to Cloud Ops Craft. We will simplify cloud and DevOps concepts every week. Thank you.